Hey, hello everyone. Welcome to another session of this cloud data architecture series. Uh, in today's session, what we'll have a look at is the audit table for data ingestion. Um, and we will see some of the methods to do that. What are the different approaches? Why this is really needed. But before that, right? Let me set the context. What do you mean by an audit table for a data ingestion process? So this session is mainly intended for all the data architects or even tech leads or data engineers or the ETL designers who are working on designing a solution for any data ingestion or data extraction kind of a process where they are extracting data from some source systems or they are trying to um, load the data from any of the flat files into their target system. It can be a warehouse, it can be any sort of database, or it can be a data lake as well. It's more of a generic session, I would say, and it will help everyone who is trying to create a design that can help in the longer run as well. In When I say longer run, it should be a scalable design, and it should help you to eventually accommodate other data sources as well, not just the current data sources that you have. Though there are slight variations. Mainly we'll talk about the batch feeds today. We'll not go into real time related ingestion mechanism because that can get a bit tricky and complex. Let's keep this for batch processes for the moment. So let's get started. uh, what is the data ingestion? Whenever you have to load a data from any external systems into your warehouse or your data lake, you'll need a data ingestion system. Okay, now this external can be a RDBMS database from where you are pulling the data, or it can be some flat files which are already present on your server or in the cloud from where you have to ingest the data, or it can be some APIs that you have to hit and get the data. It can be anything. And for real time, it can be some streams as well. But as I said, let's not get into a lot of into the streaming applications. Let's try to focus on batch. So let's say you're trying to load some data from some flat files like the CSV files, and you want to load it into your target warehouse. Right? Let's say you have a source as a CSV file, you have a target as a warehouse. It can be any warehouse for that matter. We'll keep this session generic. Will not depend on any specific tool. So from warehouse perspective, it can be an AWS Redshift, it can be a Snowflake, it might be an Azure Synapse, it can be anything. Okay, or even if you're trying to load it into a data lake as well. Fine. Say okay, so you have a file, CSV file, and you're trying to load it into warehouse or a data lake. Now, when you are loading this kind of files, now it's fine if it just end of the day process, right? If you're getting just one file a day, okay, so that just one file and you have to keep a track of one file. But in actual real implementations, right, it is never just one file. There will be multiple micro batches of the same file, or there can be multiple such feeds that you are receiving, and it is very important to keep a track of all these things, right? Like how many files were loaded at what time, right? You should be able to track that, because once this system gets into production, right, imagine the production support engineers, they'll have to keep a track of all these things. There should be enough checks to highlight if there are any failures or any late arrivals of these files. So for that, as an architect, right, you need to make provisions for all these things. And today we'll talk about how to do all these things. And one of the very effective ways to do that is using a um, audit table or control table, okay, for such data ingestion process. So before we get on to what the audit table is and how should we design it, let's try to understand why it is really needed. Okay, for anything for that matter, right? When you are trying to design something, or if you are trying to architect any solution, right? It's very important to understand why. Okay, once you understand the why, how to do that becomes much easier. So you need to understand why we need an audit table here. Okay, So let's see some of the reasons to have an audit table. Okay, so in this case, right, let's say we have a CSV file, but there are multiple CSV files, okay, of or the uh, same data. Let's say we are trying to ingest a customer data, and we get this file as a micro batches, okay, after every 1 hour, 7 o'clock, 8 o'clock, 9 o'clock. Okay, it's not just a EOD file. So in a day, you are getting this file 24 times, every hour, one file. Now you need to know which file got ingested, okay, at any point of time, any given point of time. So you need to have that tracking mechanism somewhere. You need to have this in the audit table, okay. So that is one of the reasons to know which file got ingested, okay. How many records were ingested, okay. Let's say the first file had 100 records, so you need to know whether all those 100 records got ingested or anything got rejected. Okay, it can happen that, right, see, you this is a ETL process. During ingestion you might be doing some kind of transformation. Again, it depends from your business logic. uh, you might be doing some technical validations like just the metadata checks, right. You might be just checking whether some of the columns should not be null or the date columns should have the right format. You might have such checks, or there can be some business logic as well, okay. Or it can be purely an ingestion process. Still, you need to have a mechanism uh, to show the, I mean, to indicate that how many records are present in the file and were all of those getting loaded into your target system. It can be a data lake or warehouse, right? So you need to have that into the table. So let's say the file had 100 records, you need to have a column in your audit table to say, okay, the file had 100 records and 100 are loaded. Or you should also know how many got rejected, okay. Even if there is no column, okay, if you don't add this, you should be able to do that math if you have the source records and the target records, okay. But these columns are important, so at any given point of time you don't really have to go and look at the file and do a grep minus c onto your Unix system and see the count and all those things. um, then the next is you should know the time, right? When the process started, when the process completed. It's very important. Again, you don't want to go back to your UI and keep on checking all these things, right? Let's say you have a glue job to do all these things, all right? If you're using AWS Glue for this, you don't want to go to the Glue, job monitor or the Glue Studio and see what time it started, what time it completed. You need one single uh, uh, a table or one single page where you will get all this information, and that is where an audit tables comes into handy. That is why it is so important to have this audit table. uh, so yeah, start time, end time, what time it completed, for which day has the data been ingested. So as of now we were just talking about the same day, right? Now imagine this is a daily process. In a day you're running it 24 times, and it's a daily process, and there can be it is running only on the business days. It should not run on a weekend, right? So all those permutation combinations are there. So this whole table should be able to tell you all these things, right? Like which file ran on which day, for which hour of that day, how many records were inserted, how many got rejected, did it successfully complete or not, right? The status is the most important one. So you should be able to see all this details there. One another important information that generally an audit table gives is whether it was a rerun or not, right? Many a times those who have actually worked on real systems, they would know this, right? The source would send a file, and maybe after 3-4 hours they would come back and say, okay, there was some mistake, and they want to rectify that. They want to send a corrective feed. It's a very very common scenario in a production support, or actual production system. So what happens in this case? The support engineer will maybe have to manually do a rerun of that. So even this information the audit table should be able to capture. So even after 1 month, right, or 6 months down the line, if someone is doing some kind of investigation, they should be able to know, okay, this was a second run of that, so that they would know that the first run was, there was some problem, either uh, the feed was incorrect or some other processing issue was there, right? There can be n number of reasons, but the audit table should always give you all these details of what has happened. At least it should be an it should give an indication that these things have happened. Why it happened and all, there can be multiple other dependent tables on these, but the basic most important summary of this should be captured in this audit table. Okay. uh, and the last one is right, to know that all the files of that day have been completed, right? As I said, let's say in this example we are saying we should get 24 files in a day. It may happen the file was supposed to arrive at, 2 o'clock in the afternoon. It didn't arrive. Okay. The file at 3 o'clock didn't arrive, so directly at 5 o'clock you got the files, all the files from 2, 3, 4, and 5. Okay, there is a delay sometimes, right? So you should know how many files have completed, how many are yet to begin, because the next process depends on that. So if the 2 o'clock file is not, completed, but you got a sorry, the 2 o'clock file did not arrive, but the 3 o'clock file arrived, then you should not be starting that. Okay, you cannot, skip the file, because there might be some data dependency. Again, it all depends on the business logic. But in such cases, right, there should be some alerting mechanism and all. So all these things can be done using a audit table, and that is where, audit table is very very important. It can help the support engineers a lot, not just to take some, reactive actions, but also to take some proactive actions. Case in point, right, as I just said, there was a file which was supposed to come at 2 o'clock, but it didn't, arrived at 2 o'clock, and then you had a file at 3 o'clock. The system should be able to, hold on with this 3 o'clock file, and there should be an alert generated for a 2 o'clock, right? That there should be, alert generated. Okay, you can wait for 5 minutes or 10 minutes and raise an alert. It should be all inbuilt within the system, and then when the support engineer will get the mail, he can go back and look at the audit table and get all these details. So all this mechanism should be there. Okay, this audit table forms a base of, um, or I would say, not this this is not just one audit table. There would be multiple audit tables, but this is the main audit table. Let's call it the control table, the master control table, which forms the basis of all these things. And in our, subsequent lectures, we'll talk about all the other tables which are required for, such architectures. What should be there, what should not be there, or what is the best way of doing the things. We'll talk about all these things in our subsequent lectures. But as of now, let's concentrate on this, the master control table, I would say, in this whole audit mechanism. Okay, I hope you all are with me. You're understanding what I'm, trying to explain here. But still at a very high level, we have not gone, deep into this. In the next slide, we'll see how to design audit table, how it can help. Okay, what could be a possible design? I won't say this is the best design or this is the only design, because this all depends from, uh, business use case to use case. The frequency, the known issues. If you have been doing this, you know the source better than anyone else. So there are a lot of other things. It all depends on that. But yeah, this can be possible, one of the designs that I'm trying to explain here. And based on this, you can always enhance it, add more things to it, or reduce few things based on, your use case. So let me just move to the next slide. Okay, so this is an example of, one of the master control tables within this audit mechanism. And I have tried to put in, just the very very basic columns here. Uh, these are the, I think the minimum columns that you need. Maybe one or two columns you think are extra, but these are the bare minimum that you need, and you can just keep on adding few more columns to that. So let's look at these one by one and why these are needed. Okay. uh, First is the batch date, right? So uh, now this is not the execution, okay, execution date. So the start time and end time is the execution start and end time, right? What is the batch date? Batch date is the date for which you have got the file. Okay, let's say, let's take an example. As I said earlier, right, we are trying to load a customer file. Okay, it has customer details, and this is a customer dimension that your source is sending, and you want to load it into your data warehouse, your target customer dimension, the master dimension. Now it may happen that you're getting this file at every 1 hour. Okay. uh, and it is coming for each day. Now it may happen there was some issue at the source side, and for couple of days you did not get the file at all. Okay, it can happen. Okay. uh, or even a actual example, a real world example, I would say, in the night time, right? When the days at a 12 o'clock, the file which we were supposed to get, let's say at the 12 o'clock, or let's say 11 o'clock, instead of getting at 11 o'clock, you got the file at the next day. Okay, next day morning, right? So instead of you getting a file on a Thursday night 11 p.m., you got it on the Friday early morning at 2 a.m. Okay, so that date changes, right? But then what is the actual batch date? It should be of that Thursday itself. Okay, so you need to have that into your audit table. You should know for which day that file belongs to. And to extract this, right, there are several mechanisms. It may happen that this batch date is present within the header of the file, or it can be in the name of the file, right? It can be anything. Again, it all depends on how the source is sending. So you'll have to pay a special attention to that, and how to extract this, right? How do you populate this itself? Again, it's something, you will have to deep dive and understand, talk to the business, talk to the source systems, and then have the source to target mapping document for this created. Okay. So yeah, so batch date is the date for which the file belongs to. Batch ID, why you need it here, right? If there are multiple executions for that day. Okay, so let's say we are doing it for 30th Jan. Okay, and you start getting the file from morning 7 o'clock. So that is where the batch ID 01 is added. Okay, so date is 30/01/2022, and I've added 01. Okay, so in the batch ID, so 01, 02, 03, running numbers. Okay, it can be anything. Again, just an example. What is the main part is it should indicate, okay, this is a unique batch. Okay, now why this is again required, right? Because you need a unique entry by which you can identify that this is for which execution, right? In a day, if there are 24 executions of a file, you should be able to identify this is for which execution. Okay, and then this batch ID, right, you can use in other tables also. See, remember, this won't be the only audit table, right? There would be multiple such tables where you will give more details, right? There you need this. Let's say this is all done by some orchestration tool, like you are using control M or airflow or aws step function, anything. And there would be other details around that, so there will be other tables, right? You need to tie up all these things in the end. So you need a unique identifier, and that is where batch IDs are needed. Now the way it is populated, right, I've just mentioned that the batch date and a unique ID, or it can be anything as well. Okay, it can be an unique identifier from your orchestrator tool also. If airflow does produce that, okay, you can use that as well. So it all depends on what you have and if it is unique or not. If you have it as unique, you can use it. Third is obviously the feed name. Okay, for which feed you are doing that. Sometimes I've seen like many of the source system have the date as well as the time of the file creation in the feed name. You can use it as is, nothing like that. The more uniqueness you have, it is better. Okay, see, the purpose of this audit table is to help you understand, okay, what has happened during that execution. So you should be able to uniquely identify it. If you have this file with the name and the date and everything in it, nothing like that, use it as is. Okay, feed type, okay, just to indicate whether it's a CSV or XLS. See, it can be a database also, right? I've just given an example of CSV. There can be multiple different sources. So just so that the support engineer knows, okay, this is a file or it's a database, it helps. Then the start time and end time, okay, pay special attention to the formats that you are using. Okay, ensure that you have the formats right. uh, Try to have a unique format throughout the system as much as possible, so that it becomes easier for writing the reports and all those queries. See, any table that you create, right, especially these audit tables or the lineage tables or system tables, right? Eventually these gets used in some kind of reports, right? It can be an MIS report, it can be the metrics report, not utilization but the performance reports, execution time reports and all. It's better to have the time formats standard and consistent, so that it is easy and you don't really have to change your reporting templates every now and then. Then you can have the records in source and target. So how many records were there in the source? If there were 100, just do a wc minus l on the file and put that, whether you keep the header or you remove the header, whether you keep the trailer or remove the trailer, right? All depends whether you have these in there. So uh, understand the data, right? Analyze what you're getting in the source system, and then jump into all these things. If there is no header, there is no trailer, it's fine. Sometimes there are files which do send couple of headers also, right? uh, the first is just a info about the file, like the batch date or the sequence id. Then the second is the actual columns. So you may have to trim those first two records. Some of the files may have a trailer record, so you'll have to trim that as well. So consider all those things, put that into the source. And then finally, how much after loading, right, the data ingestion process is complete, then how many records went into your target. Now here, see, the ingestion process can be a 2 layer or 3 layer, right? It all depends on architecture that you have. Whether you're just moving from the landing to raw, that's the first layer, okay? Then from raw to maybe curated, that's the second. So you'll have an entry for every layer, okay? It's not just one entry for all these layers. Either you can have multiple columns or you can have multiple entries, again your choice. See what is required. I would say keep it as simple as possible. Keep your designs and all your tables, right, everything as simple as possible, so that it is very easy to query it later, okay, and make any changes or make any modifications will happen, okay. You'll have to keep on adding some columns later. Enhancements will keep on happening, so try to keep it as simple as possible, so whoever is working on these things later, right, they don't have to struggle with all these modifications. There are two reasons. One is it is easy for them to understand, and it is easy for them to modify the things. Both these things are important, so please keep that in mind. So yeah, if it's you're moving from landing to raw, you give the records in your target, okay, and then it should match. Okay, I've not given that kind of a validation kind of a mechanism here, okay. But if required, you can do that. You can do that math. You can have that calculation in your code, and it is not when you say the status, you want to not just show whether the process got completed or not, but whether it successfully loaded everything or not. Okay, by that what I mean is, if the record count was not matching, let's say in source there was 1790, okay, the first record, and in the target, right, I'm talking about this, okay, the source there was 1790, but in target there were just, let's say this record was 1760, so there is a gap of 30. So you can have that in your code and say, okay, this is not matching, so this has failed. Okay, you can have that mechanism also. Just for simplicity sake, I have not considered that here. Here we are just checking whether the process completed or not. Okay, but you can have that kind of mechanism. You can have another table depending on this. You can tie this and that table using this batch id which is unique. Okay, you can do several other things. Okay, but have this status completed, right? So once you start getting this entry, suppose you have this kind of a table, you have started getting the entries. Let's say you got a file at 7, it got completed at 7.5. Then you got another file at 8, it got completed at 8.1, because number of records were less. See, you can figure out all these things. This table is going to build a complete history. You can do a lot of things from this table later, right? It can help you to get the execution timings. It will help you to get the long running jobs. It will help you to understand, okay, whether there are any spikes in any file at any particular day or any particular time of the day, right? To understand all those things, it's going to help you to have your capacity planning, to resizing your cluster. A lot of things can be done using this table, right? Those who have worked on this, they will understand what I'm trying to say here and how these things can be utilized. Okay, now the third one, right, where I have kept end time. Okay, end time I have kept it blank. That is because uh, you should be able to see if a file was being processed and it got aborted. Okay, in that case, it won't populate any end time, and you should get an entry as failed. Okay, so if something goes wrong, the table should be able to capture that. Okay, now rerun. Now the support engineer will go and check what has happened and then take appropriate action. Suppose there was an issue in the file and he got the right file. So when you get again this file, there should be there can be a new entry for this. This failed, let it be here only, and you have a new entry for this file. Okay, and it can be as 03 only, but it's a new entry, but it's start time, right? Instead of starting at 9, it started at say 9:45, because you had to spend that time in all these things, and then it got completed. Okay, so now you should be able to understand, right? The file at first failed and then it got completed. Okay, don't update this. Okay, don't update, because then you won't have that history. Or I have seen some of the designs, right, where you will just update this, but you will move this to some other table. Okay, history table, even that is fine, as far as you are getting that complete history, that okay, this file had come at 9 o'clock. Okay, okay, one field I missed here is, okay, I've given start time, I have not given arrival time. Okay, you can add that as well. Okay, if required, what was the arrival time of a file and what was the start time? It can also be different. Okay, see, you can play around with this. There are n number of combinations you can do. Okay, I'm just telling you the bare minimum, but I just thought of explaining this while talking about it. So yeah, coming back to this, right? So you need to have that history that a file was had arrived at 9 o'clock, but it had failed, there was some issue, then it again arrived at 9:30, which has started processing at 9:45, and then it completed. Okay, so the whole history should be there, either in this table or you have another table where you move this. Even that is fine. Okay, but you should be able to give that history. Now, how it helps is, right, later after 1 month or 2 months, let's say there is a file which always is a problem at the file that comes at 9 o'clock. Let's say there is always a problem, right? This happens for 7 days. Then in your weekly report, right, you should be able to identify. Okay, see, there are multiple such files, thousands of files you are processing in a day. You won't realize this until unless there is some focus efforts on that. So all these things will be captured in your weekly reports, monthly reports, right? Where you will say, okay, how many files had got failed. Okay, then you will try to see what is the pattern, right? Okay, then you will understand, okay, 9 o'clock file daily it aborts, that means there is some issue. Then you will have to take it up with the source system, right, your business owners and the business users, and accordingly you take a decision on this. That is how you make use of this table. So yeah, I mean, this is just a basic of an the control table in this whole audit framework for data ingestion. There are multiple things that we can do about it. Maybe in some of the subsequent lectures we will talk more about these things. We'll try to add few more things. But for today's session we'll stop here. Okay. Just to summarize, right? What are the the key takeaways from this session is, uh, number one, have a audit table or control table in your audit framework for your data ingestion first. Second, have the at least minimum attributes in there, okay, which are required, like the execution date or the batch date for it is being processed, start and the end times, its completion status. Okay, and third is capture all the history. Okay, do not overwrite anything. Okay, even if you are overwriting in that table, you keep it the history somewhere else, but capture the history, because it will help you in the longer run to identify the issues and take some proactive measures. Okay, rather than doing some reactive measures, it will help you to do that. Now this, whatever we talked about, right, it is not specific to any tool or technology. These are very generic patterns or architecture design related um key considerations for any data system that you are trying to build in AWS, Snowflake, Azure, Databricks. You can apply it. There are multiple tools and technologies. There are platforms which can do this for you. There are a lot of platforms, I believe now, or the tools that can capture this in an automated way. Make use of that. If you already have these tools doing it for you, nothing like that. Some of the orchestration tools would do it. If you are using Airflow, I think it has a lot of features. Snowflake has its own, I think, auditing mechanism to see how many records were inserted by a file. Make use of all of these. Okay, don't try to again implement something which is already there. It is just as an architect, it is important for you. You have these control mechanisms in place. Okay, how do you leverage the tools and all? It is based on your choice of tool, or your expertise, or your team's expertise in there. If you already have it, use it. If it's not, then only go for custom custom code for all these things. But with all these modern technologies that I've seen, most of the things are there. It is just in a matter of putting all these things in a right place, uh, connecting all the dots, and having that summarized view, so that you get some nice fancy report at the end of the day, so that your production support engineers will be pretty happy with all these things. And that will definitely make their life easy. And if anyone from the senior management would ask them for any reports, or any root causes due to such failures and all, it becomes much easier for them to pull out these reports, or just refer to this. Because see, many times they have to work midnight and see what has happened and what went wrong. They don't really want to log into the systems and get the details and all. Just a report which is being triggered from this table, an email, really makes life much simpler. So yeah, it's all about bringing in that simplicity to all these complex systems. um, the much simple it is, much easier it becomes to maintain the systems. So it's not just building the system, but also maintaining the system. That's it for today's session. Maybe hopefully in next session we will talk more about some other such use cases and how to implement these. Thank you for being with me and listening to me patiently. Have a good day ahead. Bye bye.